next few problems, which is the sixth one. So here is cos x cube and sin square x power 5 is there. So we can consider these two are the composite function. Why? Because this is a cos x cube is there. Cos is a trigonometric, x cube is a algebraic. Therefore, this is a one composite. Again, sin square. Sin is a trigonometric, x power 5 is a algebraic. Again, you need to consider this is another composite. Now, you can take it, this is a one complete function and you can take that is a u. And this is the another one complete function, you can take it as a v. Now, you should go with a product rule, that is uv rule. So, now I just go with that. We know that d by dx of u into b. The product rule is, you need to differentiate the first function, a derivative will just denote it as dash, u dash. Is nothing but derivative of the first function. Keep it the second function as it is. So after that you need to make use of a plus only in a product rule. Next is you need to keep it the first function as it is and you need to differentiate the second function, that is v. So now I'll just apply this rule for this composite function. Now u is a cos x cube. We need to differentiate that. So I'll just go with the alternate method. I'm not going to use a chain rule. Okay. So here is derivative of cos x cube is first differentiate cos. Cos is nothing but minus sine. For this function variable is a x cube. It is a composite. Again you need to differentiate this algebraic term. Therefore d by dx of x cube. Oh, this is clear. So this is the derivative of a u dash. Next is, you need to write the v as it is, that is the second function, sine square x power 5. So this is about this. Okay. Now you just write the plus. Next you need to write the u as it is, that is the first function as it is, cos x cube. You need to differentiate the sine square x power 5. If it is a sine, you can write it as a cos, but sine square is there. That means I just make use of d by dx of sine of n into x. If this is some positive power of a trigonometric function, we can write that as n into this derivative of sine of n minus 1 into x. Again you need to differentiate sine x. This is what the formula for trigonometric when its power is a positive number. Clear? This is a sine square. If it is a sine, you could have write it is a cos. Derivative is. But sine square is there. That means 2 into sine 2 minus 1 into x. Again you need to differentiate the sine. Is it clear? Whatever the power, if it is a sine power 5, you need to write that as, if I write this is a sine power 5, you can write that as a 5 into sine power 5 minus 1 will be a 4x. Again you need to differentiate only a sine, not a power of this function. Hope this is understood? Okay. So your sine square is there. So I'll just differentiate that with the help of this one, which is derivative of a sine square is 2 into sine square will be 2 minus 1 will be a 1, and for this variable is a x power 5. Again you need to differentiate the sine. For this variable is x power 5. So as I said that this is a composite, we differentiate this sine square. That means again you need to differentiate this inner function, that is d by dx of x power 5. Don't mess up the step. Clear? So here is minus sine x cube. Derivative of x cube is 3x square. Is it right? So variable power is, the power will comes to like a product and one power will be a decreases. As nothing but x cube is there, you will get it x square. Next is sine square x over 5. Then plus cos x cube into 2 sine x over 5. Derivative of a sine, only a sine. Okay, sine is a cos x power 5 into x power 5 derivative is power will comes like a product and one power will be a decreases, hence it is x power 4. So the last step is, you just write, you just leave it the trigonometric terms or some functions. First write the negative and some algebraic terms and a constant. So minus is there, constant is a 3 and variable x is only a square is there. So 3x square I'll write first. Remaining terms I'll write it next. That is the sine x cube, sine square x power 5. This is the first term. Next, the second term is, the constant is 2 is there, 5 is there. 2 into 5 is 10. Next, the variable is x power 4. You just write the remaining trigonometric terms, that is cos x cube and cos x power 5 and a sine x power 5. So I'll just write it that as cos x cube, sine x power 5 and cos x power 5. Hope this is clear. So this is what answer for this composite function. Or you can write this is a 2 times is there, 2 sine x cube, cos x cube is there. Either you can make use of a sine 2x formula because x power 5 same. So 2 sine x into cos x is sine 2x. So you could have write this as 2 sine x power 5 and cos x power 5 as a sine 2x power 5 also. Okay, I'll just write it here, or if you remember at that point you can write it, or else you can stop it by here only. So minus 3x square sine x cube sine square x power 5 plus, I just write only a 5 because I just make use of this 2. So 5 x power 4 and the remaining is cos x cube, this one and this one, 2 sine x power 5 into cos x power 5. I just write it as sine 2x power 5 because sine 2x is 2 sine x into cos x. Okay, so this is what the answer for the given a composite function and that product it is. So this is what the 6th one. I'll just move on to the 7th. So 7th one is, which is, it is a 2 times square root of cot x square it is. Okay, which is like, I can consider this inner function as a variable x. The whole thing is a x, but it is a composite, right? So now the square root of the derivative of root x, which is 1 by 2 root x. I just make use of this derivative. So now x is nothing but this cot x square. So derivative of this will be, it is a 2 into constant as it is. Derivative of this is 1 divided by 2 root x. X is nothing but this. So cot x square. Again you need to differentiate this inner function. Therefore d by dx of only a cot x square. Clear? So now this 2 get cancelled. 1 divided by, cot can be written as cos by sine, right? So cos x square divided by sine x square. Now the derivative of a cot, which is minus cosecant square. Here the variable you need to write the inner function, that is x square. Again you need to differentiate this because this is a composite function. If it is only a x, cot x, you can write it as minus cosecant square x. But it is a square, hence you need to consider this is a composite. Therefore, you need to differentiate again that inner function is x square. Now, I just write this as, I take this denominator of denominator that goes to numerator, right? It is with a square root. Therefore, a square root of sine of x square divided by square root of cos of x square. So here remaining is, so x square derivative is, here minus is there, I will write minus, x square derivative is 2x, cosecant can be written as 1 by sine, square is there, so I can write that as sine square x square. Is it clear? So now I'll just write, I'll remove the square root. If I remove the square root, the value for that function is 1 by 2, right? Okay, the value for the square root is 1 by 2. I just remove this one, so instead of that I'll write 1 by 2 divided by square root of cos of x square. Next, this one is minus 2x divided by sine square is there, is nothing but sine into sine will be a sine square, right? So I'll just write it this one term as a twice. Is nothing but sine x square into sine x square. We can write, no? Next, what I will do the substitution is numerator and denominator. I just multiply with a root 2 and a root 2. Because I need to simplify this one. So for that sake, I just multiply and divide by a root 2. So what you get is, if I take this function to the denominator, the power of this function will be changes with a sign, only a sign. So if it is a x square in a numerator, if I take this numerator term to the denominator, you will get x power minus 2, right? The same way, I just write the sine x square whole power 1 by 2 to the denominator, you will get sine x square of minus 1 by 2. Okay, so we can write that as, so here remaining is minus 2x and root 2 this. So root of cos x square is there, root 2 is there. So we can write together within the square root 2 cos x square. So here I'll just write this numerator term to the denominator, hence its power will be changes. There's nothing but only the sign. So sine x square here, one more sine x square and sine x square power minus 1 by 2. This is of this. So we can write that as minus 2 root 2x divided by, so square root of, I'll write directly because you guys are in PO, I can't explain all the basic. So here I can write sine x square into sine x square power minus 1 by 2. If the bases are same, we can add with the power. Is it clear? So here is the x and x power is minus 1 by 2. If the bases are same, we can add with the power. Is nothing but x power 1 minus 1 by 2. Is nothing but 1 minus off. So you will get it off. Okay. So here's nothing but, you can write this is a root of x. The same way, in the place of x, here is a sine of x square. Okay. With the help of this one, I can write these two terms as a root of sine x square and write it here sine of x square. Remaining is one more term, that is, it is out of the square root. So sine x square. Oh, this is understood. With the help of this, I just wrote it directly, that is sine of x square. Now minus 2 root 2x divided by, I just make use of a trigonometric formula, that is 2 sine x square into cos x square as sine 2x square. because we know that sine 2x can be written as 2 times sine x into cos x. Here in the place of x we have only a x square, right? The variable is the same for both the function, hence you can make use of this formula and I can write this is a sine 2. In the place of x we have x square. Okay, and one more sign, it is out of the square root, therefore sine x square. This is what the required derivative for a given composite function. Hope this is understood. Okay, so I'll just move on to the next and a simple one, that is eighth one, which is a cos of root x. Okay, the last and a simple one, it is cos derivative is, which is alternate method. I'm not gonna apply a chain rule. Okay, so cos derivative is minus sine. For this function the variable is nothing but inner function is root x. This is a composite, hence you need to differentiate this inner function. Therefore, d by dx of inner function is root x. Hence, we can write this as minus sine of root x into derivative of root x is 1 by 2 root x. Or we can write this as minus sine of root x divided by 2 root x. And don't cancel out these two guys. Okay, you guys will do this one. This is root x is with the function. If you cancel out this one, then it is a meaningless. Okay, we can't cancel out these two. When this root x is alone, then you could have cancelled out this one. But this is with the function sine, hence you can't cancel this term. Okay, therefore this is what the derivative for a given composite function. Okay, last one I do, that is a 9th one. The same way you just do it a 10th one. Okay, that will be the second exercise in this chapter, which is a different type of a problem. The question is, prove that the function, so 9th one, prove that the function f given by f of x, which is equal to mod of x minus 1, where x is in a real number and is not differentiable at x is equal to 1. This is what the question. So question is, you need to prove that the function is not differentiable at x is equal to 1. So what type of a function? It is a modulus function. So where exactly this x value means, it belongs to the real number. Now you need to prove that only at this point this function is not a differentiable. So how can you prove this not differentiable is nothing but, here is the two cases, that is LHL is nothing but left hand limit and RHL right hand limit. Left hand limit is like a negative value of this modulus function. RHL is nothing but the positive value of the given modulus function. Once you apply the negative value for this modulus and positive value for this, if you get it, once you apply the limit, if you get the same value, then it is a differentiable. Once you apply the LHL and RHL for this modulus function, the values are different, then you can say that this is not a differential. That is what we are going to prove. Okay. So now, so I'll prove this one with the help of a limit definition. Okay. So here is, let f is nothing but f of x. The function is minus 1 at x is equal to 1. I'll consider this one. So now we know that the limit definition tends to 0, f of c plus h minus f of c divided by h. Okay, so this is it true for all the real values of x. So now I'll consider LHL for this definition. So limit x tends to 0 minus I will take. Why? Because LHL is nothing but the negative value of the x. So 0 minus f of c is nothing but it is the domain of the function. Domain is nothing but the value of x. So this will take it as a domain, that is the c value. So therefore c is a 1 plus h minus f of c is nothing but the domain value divided by h. So now the limit x tends to 0 minus, so f of 1 plus h is nothing but the function is f of x is modulus x minus 1. In the place of x we have 1 plus h. In the place of x 1 plus h. So in this function in the place of x replaced by 1 plus h. Clear? So function is a modulus. In the place of x you just write it 1 plus h along with minus 1. Okay? Minus f of 1. F of x is modulus x minus 1. F of 1 is nothing but modulus 1 minus 1. Therefore, which is modulus 1 minus 1 divided by h. Here plus 1 minus 1 get cancelled. So remaining is limit x tends to 0 minus. So modulus remaining is h minus modulus of 0 is it is a 0 divided by h. So now you need to apply the limit for h. So h is, you need to take it as a 0 negative. So modulus of this h value is a minus h. Why? Because this is a LHL is nothing but the negative value of h. So minus h divided by h, and this is of minus 1. This is the value of LHL. The same way I just do it the RHL. So RHL is the same way I'll do it. RHL is nothing but the limit x tends to 0 plus. It is a positive value of the modulus. F of, again the domain is the same, 1 plus h minus f of 1 divided by h. Now the limit x tends to 0 plus, the same way you just do it. So modulus of 1 plus h minus 1 minus 1 minus 1 divided by h. Now the limit x tends to 0 plus, plus 1 minus 1 cancel, plus 1 minus 1 cancel. Remaining is modulus h minus 0 by h. Now you just apply the limit for a h. It is a positive value. Therefore the modulus of this h is positive h divided by h, and this is plus 1. Now if you compare for this domain value x is equal to 1, LHL we got it as minus 1, whereas RHL we got it as a plus 1. Plus 1 and minus 1 both are not equal. Therefore the modulus function is not differentiable at x is equal to 1. Is it clear? So now I can conclude the problem. So here, so LHL and RHL are not equal at the domain value is x is equal to 1. Therefore, a function f of x is equal to modulus x minus 1 is not differentiable. At x is equal to 1, and ends the problem. Hope this is understood. The same way you just do it the last problem in this exercise.